Alright, so the last section that we're going to be doing in Chapter 9 is 9.5. So trig equations. It is inequalities, but we're not really going to be doing the inequalities. So here what we're going to be doing is we're solving each equation for solutions over the interval 0 to 2 pi. So what this means is you're looking for all the solutions included in the unit circle. Now you're not including 2 pi because technically when you say 0 you're giving the solution for 2 pi, so we're not including 2 pi, okay? So what that means is, for example, if you end up with sine of x is 1/2, this is not, or plus or minus 1/2, let's say it is 1/2, just 1/2. Your answer is not just going to be pi over 6, but your answer is also going to be 5 pi over 6, because at those two places, sine of x is 1/2. Alright? So before we start, I have like some rules that you can follow. I will make this copy for you guys and give it to you guys on when we do this in class. But basically, these are just some steps to how to solve a trig equation. So first off, you're deciding whether the equation is linear or in quadratic form. Because if it's linear, then you're just going to solve it just like a y equals mxb equation. If it's quadratic, you're going to have to factor something. Step 2, if only one trig function is present, then solve the equation for that function only. If more than one trig function is present, you're going to rearrange the equation so that one side equals 0, and then you're going to try to factor and set each factor equal to 0 to solve using the zero product property. Okay? So basically, if we end up with like x plus 1 and x plus 1, or x plus 2, you would solve this and get two solutions. You'd get x equals -1. You get x equals -1 and x equals -2. Step 4, if the equation is in quadratic form but is not factorable, you can use the quadratic formula, and then you check the solutions for the desired interval, which in this case is going to be the full unit circle. And you're always going to try to use identities to change the form of an equation to help you better solve equations. Okay, so these are 5 rules to kind of follow. So let's try solving our 6 equations. So the first one over here, it's obviously linear. There's no squares, it's not quadratic. So this is pretty straightforward. Just solve it like you're solving for x. So the first thing we do is we subtract 1 on both sides. So you end up with 2 sine of x equals -1. And then you divide by 2. So you get sine of x equals -1/2. So the question is, where is sine of x -1/2? So on our unit circle, sine of x, remember, is y. So where is y -1/2? Obviously it's not here. Obviously it's not here. So our solutions are going to be right here. So one of our solutions is 7 pi over 6. Another one of our solutions is going to be 11 pi over 6, because here's the other place where sine of x is -1/2. And you have to write both solutions because we are looking for solutions on the full unit circle. Alright, so that one was pretty straightforward. So here it's still linear, it's not quadratic, so you solve it just like a linear equation. So because we have secant in 2 spots, we can combine like terms. So if you subtract secant from here and subtract secant of x from here, you end up with, what's 2 secant of x minus 1 secant of x? You have secant of x plus 1 equals 3. And now you just continue this. So -1, -1, and this is secant of x equals 2. So remember that secant of x is the same thing as 1 over cosine of x. So basically, for 1 over cosine of x to equal 2, what that means is that cosine of x, because it's in the denominator, has to be 1/2. Because when it's 1/2, then 1 divided by 1/2 will give us 2. So where is cosine of x 1/2? On our unit circle, cosine of x, which is the x value, is going to be at pi over 3 and 5 pi over 3. So those are our two solutions. Okay, so far easy, right? All right, the next part, we are still linear, so we want to set this equation to equal 0, because we can't really solve it like this where we're combining like terms, because on this side we were actually trying to set it equal to 0, but we realized that when we moved over secant of x, we were left with 1 secant of x, so we solved it like this one. So here, when I move this over to set it equal to 0, what this actually ends up doing for me is I can see that I have a common factor between these two terms. So I can factor out a sine of x, so we're left with cotangent of x minus 1 equals 0. And here we have two terms, and we can use the zero product property to solve this. So one side is sine of x equals 0. And this side, when we set it up, cotangent of x minus 1 equals 0. We'll come back to this in 1 second. Now the solutions for sine of x equals 0, where is sine of x 0? It's going to be at 0 and at pi. So for this side, our answers are 0 and pi. Remember, we're not including 2 pi, so we're not going to call this guy 2 pi. We're calling him only 0. And on this side, we have to solve it first to be able to get to our answer. So we set it up, cotangent of x is equal to 1. So where is cotangent of x equal 1? Remember, cotangent is the same thing as cosine over sine. And where is the only places where you end up with 1 for your cosine and your sines is at the quarters, right? When cosine and sine are the same and you divide them and they end up being 1. So where are they 1? At pi over 4. Now on this side we don't get positive 1, we get negative 1. So that's not one of my answers. But the other answer comes from down here, because a negative divided by a negative is positive. So my answers for this side are x equals pi over 4 and 5 pi over 4. So our 4 solutions for this problem are 0, pi, pi over 4, and 5 pi over 4. All right? So this problem, don't try to complicate it by distributing and doing all that, because remember, even if it is in a quadratic equation, you want to factor it. And we're lucky here because it's already factored. So when it's already factored, we can use the zero product property right away. So we set both sides equal to 0. So this is cotangent of x minus square root of 3 equals 0. And this is 2 sine of x plus square root of 3 equals 0. So when we solve this, cotangent of x equals square root of 3. And I'm going to solve this guy. I'm going to do them in one step. So I'm going to subtract square root of 3 and then divide it by 2. Okay? Now this side is easy because it's just sine of x. So let's solve this side first. So where is sine of x negative square root of 3? Sine of x, remember, is our y. Obviously, not over here. Again, not over here. So our answer for negative square root of 3 over 2 is at 4 pi over 3 and at 5 pi over 3. So our two solutions for this side are 4 pi over 3 and 5 pi over 3. Alright, now on this side, remember that cotangent is the same thing as cosine over sine. So when do we end up with square root of 3 for cosine over sine? It's basically going to be at the sixes, because at pi over 6, cosine over sine is square root of 3 over 2 divided by 1 over 2. And remember, when you flip the guy and multiply, you actually end up canceling out the 2's, because times 2 over 1, that's gone, so you end up with square root of 3. So basically, I now know that my answer is going to be square root of 3 wherever cosine is square root of 3 over 2 and sine is 1/2. And that happens here at pi over 6. It does not happen here because this will give us a negative square root of 3, but it does happen right here because two negatives give us a positive. So our solutions here are going to be pi over 6 and 7 pi over 6. So we have four solutions: pi over 6, 7 pi over 6, 4 pi over 3, and 5 pi over 3. Okay? Alright, now this next problem is obviously a quadratic, and if you want to use substitution to kind of help you to factor it out, you can. We have cosine and cosine here, so I'm just going to basically let u be my cosine just to help me factor it out using a regular quadratic equation. So if u is cosine of x, then this side right here is going to be u squared plus 2u plus 1. So when I factor this down, what are two numbers that multiply to 1 and add to 2? And that's going to be 1 and 1. So we end up with u plus 1 and u plus 1 equals 0. So now I'm going to substitute back. I know this one's an easy one, but you could possibly get a harder one where you actually have to, when you factor it, it's not perfect like this. So I'm going to plug in cosine of x again, back in. And you see that this is a perfect square, right? So I'm going to set it up as cosine of x plus 1 squared equals 0, because that's exactly what I have. Now, with the zero product property, remember, if you have two of the same, you only have to solve one of them. So cosine of x plus 1 equals 0, minus 1, cosine of x equals negative 1. So where is cosine of x? Negative 1. It's basically only at pi. Nowhere else is cosine of x negative 1. So our only solution for this problem is pi. Alright, this last problem. Now when I first tried to solve it, I was like, okay, let's get these on the same side. And then I was stuck. I'm like, they're two completely different terms. I can't even use substitution to factor it, and I can't really change sign. I could possibly change sine of x to 1 minus cosine of x. I could do that, but I found an easier way. Alright, so basically what I did, instead of subtracting sine of x from both sides. I was like, all right, what if I divided by sine of squared of x over here? And if I divided by sine squared of x over here? What that gives me on this side is a 1. And on this side, I end up, what's cosine squared over sine squared? It's tan squared of x equals 1. And then you take the square root of both sides. And remember, because this is solving, when we take the square root of both sides, we end up with tan of x equals plus and minus 1. Okay? So it's not just positive 1. So our question is where is tan of x both positive and negative? And we know that it's tan of x is sine over cosine, and we know the only place that they equal 1 is at the quarters. So it's basically all the quarters because we care about both positive and negative. So at pi over 4, tan of x is positive 1. At 3 pi over 4, tan of x is negative 1. At 5 pi over 4, tan of x is positive 1. And at 7 pi over 4, tan of x is negative 1 again. So that gives us all of our solutions. Okay? So this is a pretty straightforward section. It's just basically solving. The key is to remember your unit circle and just understand that if it's linear, it's straightforward, you solve it like a linear problem. If it looks like a quadratic or a factorable problem, that's what you want to focus on. You want to try to factor it. And if it's like this, you can use the identities. Yes, I could have made this cosine squared of x minus 1 minus cosine squared of x equals 0, and then gone through and solved this. Alright, so because I have cosine squared of x plus cosine squared of x, I could have had 2 cosine squared of x minus 1 equals 0, and then you end up solving it, you'll get the same exact thing. So cosine squared of x equals 1 over 2. You take the square root of 1/2, which becomes cosine of x is 1 over square root of 2. You rationalize that denominator, so you end up with cosine of x is square root of 2 over 2. And where is, and of course, I forgot this, but because I took the square root, this is going to be plus or minus square root of 2. And where is cosine of x? Positive square root of 2 over 2 and negative square root of 2 over 2 at all of these places. So this was like 2 ways to solve one problem. Okay, so one way I just used straight up math, and the other way I used a trig identity. Alright, so pretty straightforward section. This is pretty easy. If you want to get started on the homework that's up here, you can go ahead and do that. If not, of course, we're going to do it in class together, but just to get some extra practice. Alright, enjoy. Good night.